Sustainability and environment. We take stuff from the earth and then we discard it back into the earth. And sometimes we take carbon out of the ground and we put it back in the atmosphere. Not so great. Things like that. Leaving polluted air, water, and land. Sustainability, long-term. Sustainability is what sustainability is. It's meeting the needs of the future while meeting the needs of the present. Not meeting the wants, by the way. We might have to make sacrifices. We might have to sacrifice what we want and look at what is really needed. Wise resource uses. Not easy. It's hard to sacrifice today's convenience for tomorrow's needs. Consider the impact of what you do and across multiple generations. We as engineers have a lot of impact. Designing the product, sustainable designs, producing it, support, disposal, and what are new ideas that we can use. We'll get to disposal later. The service and support, let's see, design. Do we design for reliability? Do we design for longevity? A lot of times we don't. We design products to wear out quickly so you come back and buy more products. Or we design products for obsolescence. Your cell phone is obsolete in a couple of years and you go buy a new cell phone. I'm cheap. So I've had the same computer now for 4 years, same laptop for 4 years, and I've had computers for up to 7 years before they really became obsolete, before new software demanded I had to change. So I try to keep around the old stuff, and in our modern day and age, if you get a good computer, a high-end computer, it will last you, it will serve you well for many, many years, not 1 or 2 years. Okay, product life cycle. Dig stuff out of the earth, you extract it, the mining, you process it in some way, you produce it into a product, you distribute it. All of these are controlled by engineers. Here's what I was talking about. People that I was talking about earlier, the Venn diagram, people, planet, and profit. Plastics in cars, sustainable. Washing machines, how much water and electricity they use. How much does it take to manufacture them? I have a washing machine with plastic parts. That's another win-win. I'm not a big, disposable plastics I think are a bad idea. You see me with my water bottles. I don't use saran wrap, things like that. I use a hard plastic cover for things when I microwave them instead of saran wrap, disposable saran wrap. I use a non-disposable plastic product. And it's just as easy. It saves money too, for that matter. So the water use, designing things so they use less water, less electricity, less detergent, so forth. Photocopiers, same way. Energy saving. Wind turbines, the manufacture and maintenance, how much they produce, how serviceable they are, how long they will last. Automobiles, same thing. Oil, antifreeze, batteries, tires, etc., filters, maintenance. I own an electric car for commuting, and it made infinite sense because it gets the equivalent of 100 miles per gallon or more. And I do have to replace the batteries every so often. It's been going it's a 2013, so it's 7 years old now. The batteries are doing pretty well. It doesn't have a lot of range, but then again, I don't need a lot of range. for commuting. And I save a lot of money on energy costs because it gets such high mileage. And then it doesn't even have brakes. I don't have to service the brakes even because it's electromagnetically braking. Really, really good. Aluminum. When you mine it out of the earth, it takes a lot of energy. But if you use recycled aluminum, it's a lot less energy. Recycled aluminum is cheaper than mined aluminum. That's kind of interesting in and of itself. So we impact all of these, engineers impact all of these stages of the process. So what can we do to get that win-win-win? We want the win-win-win right there, the middle. End stage of life. We build our product's reliability, and businesses are not interested in that. They want you to buy more stuff. We do not have an economic payoff for making products more reliable. The economic payoff is that you keep making products. You sell more and more products. You throw away stuff that's still serviceable. And that's one thing though. Let's see. Reuse. It's still serviceable. We can send it to Goodwill or something. Remanufacturing, so recovering what we can out of a product and remanufacturing. Materials processing, that's steel and aluminum and things like that. Take old cars and send them to a steel plant. Disposal, that's garbage. How do we dispose of it when we do have to dispose of things, and eventually we will? How do we put it back into the biosphere in a sustainable manner? Carbon dioxide, for example. Several ideas for coal plants is coal-fired power plants is to take the carbon dioxide that's produced and sequester it back in the ground rather than in the air. And then sustainable extraction, where mining is really good these days. In the old days though, we would strip mine and leavings were all over the place and lots of erosion, and the trees wouldn't be replanted, so more erosion, and it wasn't good. It wiped out a lot of the plant life, a lot of the biosphere. The original design. Think about how much can be recycled, remanufactured, reused, etc. Repaired. One of our 3D printers is 13 years old now. It still does a great job. It was built to last. Recovery at the end too. Think about that. How are we going to recover things? Some of it might be government. Government may mandate recovery, for example. You sell a product to somebody, you're responsible for recovering it later, or paying another company, contracting another company to recover it, and so forth. That might be what happens. I don't know how things are going to shake out. Whose responsibility? Engineers work on things people need and want. Some of them are good, some of them aren't so good. And some of these can be argued both ways. Missiles. Gee, are they good or not so good? Well, sure, our missiles harm public or environment, but the alternative is that an enemy harms us worse. Aircraft. The Boeing 787 uses 20% less fuel, which is good for business, good for the environment. Business wants to do it because they save money. But it also has a side benefit. We're saving money by burning less fuel, and therefore, and that's good for the environment too. Better for the environment, I should say better. a gas guzzler car. All these big pickup trucks you see around here, vast majority of people don't need anything that big, and they don't carry around stuff that much and things like that. It's kind of crazy the money we spend on vehicles as status symbols that we don't need for functionality. Baby crib, safety, doing it safely, but still there's a monetary incentive on business. Guns, and so on. Think about the products. So, doing an extra test in excess of the design requirements, is that a good idea? A flaw was found in a software product which slows it down. It increases the rate of program lockup. So I won't have the class discuss it. I already gave you your discussion topic. But some ideas to solve this is to one, ignore it and come out in the next release. So you can ignore it and come out in the next release. You could send a patch out later. You could offer a free update later. You could fix it later and offer a free update. Do you want to stop the release of a product and let it come, and so you're waiting on the release of the entire product for this one flaw? Most software companies have figured out they don't want to do that. They'd rather send an update later or a patch later or something like that. So that's how software companies solve this one. Summary. What we do has far-reaching impact. We have ethical codes. Resolve dilemmas a lot like the engineering design process. And sustainability, look for that sweet spot that serves business, people, and the environment. Okay, that's all, folks. That's the end of chapter 13, I think it was.